So to begin at the beginning, I started my career at IBM Research. Subsequent to that, I worked for Larry Ellison at Oracle for a number of years. Then at Silicon Graphics, I ran the commercial business unit, in addition to doing things like operating systems, compilers, chip design, stuff like that. Then I went to Applied Materials. I ran all of automation and factory automation within Applied Materials, and left there, started doing startups. I did a number of startups, sold them, then did some board work, was on a public board, had to clean up the board. Actually, the executive team fired the executive team, became CEO, cleaned up the place, and took it private. Went from $4 a share to $8.40 a share, losing money to 17% EBITDA in 7 months. And then I did a number of other startups, and then was CTO at Yahoo.
Ash, can you give a little introduction into Pepperdata?
Oh, sure. No, that introduction was fine. But yeah, carry on and then transition into Pepperdata. It's fine with me.
So that's it. I mean, I'm almost there. So then just startups. Most recently, the startup is Pepperdata. I joined Pepperdata for two reasons. One is the investors are solid and strong. And the second, the founders are brilliant. The two founders, Sean was the guy who ran a web search at Yahoo and built Bing Social Search. And then Chad, who was one of the first guys to actually figure out how to monetize search. So that's the reason why I joined. What does Pepperdata do? If you think about all the stuff that's been happening around Hadoop and Spark, people are now, so I think 5 years or 6 years back, people were starting to talk about this thing called big data. Big data was becoming popular, but no one really knew what business applications it would be. So we've crossed that chasm. We are now at the point where people understand what the business applications are. They know how to build them. They are now deploying them in production. And in fact, they're going one step further. They're operationalizing them. They're becoming part of the lifeblood of the enterprise. And if you look at operationalizing big data, you need to take the discipline that people put around DevOps and apply it to big data. The problem is that big data is a little bit of a different beast in that the number of machines that you have running is huge on a single problem. So before, when we did web serving and things of that sort, we had large numbers of machines, but they were working on essentially isolatable, segmentable problems. Now you have machines, thousands of them, but potentially hundreds of thousands of them solving one single problem, and the amount of data is 2 orders to 3 orders of magnitude larger. As a result, it requires a different way of thinking about DevOps. And in particular, performance becomes extraordinarily important. What we do at Pepperdata is provide tools to our customers to develop big data applications using Spark much better and understand their performance and debug them on these systems much, much better than anybody else. And in addition to that, we give them the ability in an operational perspective to isolate problems, pinpoint their root causes, isolate and understand hardware issues. And at the same time, we allow them to reclaim wasted resources that occur as a result of making assumptions when you first build your applications that are static. So what winds up happening is that when you run applications in real life, the static assumptions that you make are often too conservative, and you leave a lot of compute power, if you will, on the floor. We enable customers to actually reclaim that. So effectively giving them a quote unquote larger server. Typically, we see 25 to 40% improvement in hardware utilization as well. So development side, lots of tools to do development much better. And on the operational side, debugging, understanding, diagnosing, and then reclaiming wasted resources. Does that make sense?
Yeah. So the specific kind of tool that you have at the moment, as far as I can see, and you sort of mentioned a little bit, it's a code analyzer for Apache Spark. And this runs... sorry, carry on.
Sorry. So the code analyzer, so here's what happens, right? People, when they're building applications with Spark, it's a level of abstraction higher than MapReduce, which was the previous Hadoop stuff, right? And as a result, when you get one level of abstraction higher, you hide the vagaries, if you will, of the underlying architecture, underlying system. As a result, people who are writing Spark applications don't really understand how the Spark application is actually executing on a parallel hardware. And then the web UI that Spark provides gives you a summary after your application has run, and doesn't give you the details of while your application was running, how was it utilizing these parallel resources. That's what we shine a light on. So for example, in Spark, you have this notion of stages. Stages can actually happen in parallel. And what you may conclude by looking at the Spark UI is that a certain stage used a lot of CPU or a lot of memory. When in reality, when you actually look at it in a time series as to how it actually happened on the machine, you may actually find that there was another stage that was the one that was responsible. It's just the way that Spark summarized it, it wound up being in the wrong place. So by looking at things as they were happening in a time series fashion, you can actually understand how the parallelism affects the hardware and vice versa. And that's what Code Analyzer does.
And so you obviously want to use this at particular stages, and you state the coding stage, building, testing, and release. So I'm guessing you pitched a company as like a DevOps for big data. So I'm guessing that the analyzer, does it integrate with common CI platforms, or is it a separate?
Yeah. So all of this, right. So think of all the CI, think of Jenkins and all the other things that you have around. Those are, if you will, non-specific to the application domain. So those continue to exist. It's the ones that need to be specific to the things that you wind up building. So think, if you're a C compiler versus a Java compiler, right? So you sort of have to have a different set of tools around those things. You have a different set of tools around Spark and MapReduce, and those are the tools that we provide.
So,
by the way, one quick comment. When I spoke of stages, the stages I spoke of was Spark stages, not stages in the DevOps chain.
Right. Okay. So, but when, say, for example, on the product page, and it says that Apache Code Analyzer provides performance feedback to the code build, test, and release phases, that's actually the DevOps cycle. But your stages, you mentioned earlier, are the Okay.
Because Spark actually segments the job into stages.
Sure. Yep. So just, I guess, kind of going back a step into the sort of potential use cases for this. I'm guessing, you've already mentioned Silicon Graphics, Yahoo, and some other companies that for their day were very much dealing with big data of their day.
Yes, indeed.
So, I'm guessing you encountered these sorts of problems in the past, which is why you were also attracted to the company in the first place. So, I mean,
that's exactly correct.
The first question would be, like, what did you do in the past to try and figure this out, and what are the extra things that Pepperdata is doing to solve those problems you used to have?
So if you think way back, which is sort of the Silicon Graphics stage, right? That's now 20 some odd years back. We were thinking about, at that time, a 1 gigabyte disk was a big deal, right? So I built servers at that time that were 120 nodes, which was huge at that time, and that had 10 terabytes of disk. Now you sort of put that on a PC almost, right? So it was the same kinds of issues in that we always face network issues. We always face issues around parallelism. How do we understand what actually the hardware is doing? Reclaiming usage of the hardware, because abstractions of parallelism are very hard for programmers to deal with. So very similar issues, because the set of resources is the same. One of the beautiful things about computer science is that the bottleneck just changes every few years. So 1 year, for a few years, it's the network. For a few years, it's memory. For a few years, it's CPU. It's all of the same stuff. You sort of optimize around it. So in that sense, the fundamental optimization problems haven't changed. They've stayed the same. The differences are that you have scale now, which is just, 3, 4, 5 orders of magnitude than what we were used to 20 years ago. When you look at Yahoo, even when I was there, was certainly, and still today, would be considered one of the largest scale-out architectures there is. So the set of issues that we see in our customers are certainly smaller than the ones that we encountered at Yahoo, which makes it very easy for us to understand and deal with, because they're dealing with things that I would almost characterize as, cutting your teeth or toy things that we would do at Yahoo. The customers don't have the same scale, but they have the same type of problems. They have the same sets of issues in terms of deployment and making things work. And it's just happening now at places like Citibank and Comcast and places like that now.
Sure. I guess so. Are most of your current customers using Pepperdata for data analysis, or for also, is it any use in the kind of running a collection and access cluster for the data as well, or is it mainly for data analysis?
No, so it's for the whole thing. So Code Analyzer was for analyzing a single piece of code, but Cluster Analyzer, which allows you to understand exactly what's going on in your cluster. So you may have a cluster of 1, 2, 3, 4,000 nodes, and you have some jobs that are running and they're running slowly. You'd like to understand why. You'd like to understand which jobs are causing the problem. You'd like to understand that there are disks that are slowing down in your cluster, and that's what's causing the performance issues that you're seeing. We provide tools to be able to diagnose all of that.
And you also have application profilers as well, which is a sort of reasonably standard, usual part of code analysis, and policy
yes
enforcers
no.
as well. Yeah.
Right. So yes and no on the application profiler. So the application profiler is actually fairly unique in that what it does is it recognizes that programmers have a hard time understanding the paradigms of parallelism. And so what it does is it provides heuristics. Mr. Customer, I've looked at your program. Here are the things the program does. Might I suggest that you change this part of the code to use more mappers, and this part of the code to have more reducers or fewer reducers, because you'll utilize the hardware much better. You'll actually gain performance. So it's heuristics for the developer and or the operator to be able to say, here's how you should restructure so you can actually get better performance. It's a little bit different than what you would classically see in what I would call classic DevOps. Right. Then when you go to the optimizer and you go to the enforcer, what's interesting about the optimizer is the optimizer basically says, while I'm running, I notice that your hardware is not being utilized. So what I'm going to do is I'm going to ask the system to actually put more work, because I know that you're capable of doing more work. As a result, what winds up happening is you use more of your hardware more efficiently. That's the optimizer. The policy enforcer is one where you might have multiple different contentions. So you have a multi-tenant situation. Lots of different people are using the cluster. And what you'd like to make sure of is the people with the highest priority are always guaranteed a certain number of resources so their jobs are going to complete on time, because those are considered your important jobs. And the enforcer guarantees that that's going to happen at a very, very micro stage.
So it's basically making sure that these long-running big data jobs are always running as effectively as possible, no matter what that may be, based on hardware, based on
Correct.
the code, based on business priority, et cetera, et cetera. So, yeah.
That's exactly correct.
Okay. So any customers that you can mention in explicitly or implicitly?
Sure.
What
so
sort of
Comcast?
Oh no, yeah, for sure. I meant in terms of how have you helped them? How have they managed to save in time or money or resources or businesses that was never there in the first place because they were wasting time on something else? Or
Right. So HGST, we help them actually on their cloud deployment run their cloud infrastructure more efficiently, so they can actually spin up fewer nodes than they would have otherwise. So it's a real absolute cost saving for them. Comcast, we enabled them. Actually, we've enabled them twice now to defray hardware purchases, because we're actually getting about 35% additional capacity out of their existing cluster, or clusters, I should say. Right, those are two examples. We've got, I'm trying to rack my brains at this point. We've got Alan AI, who's actually using our code analyzer, because they have a bunch of scientists that are writing these complicated Spark jobs, and while they're brilliant scientists, they have not necessarily the best understanding of how to optimize their code for right. So we help them do that. Right. So those are three examples of people that are doing that. We have an example, and I can't remember the name of the company right now, but that's using the app profiler. I think it's Gamut, but we will look it up and tell you for sure. They are using the application profiler in a very unique way. What they're saying to their developers is if you run your code through the application profiler and the application profiler points out to you that there are red spots, which means there are spots that could improve performance, we will not let that job onto the production cluster. Until all of them are green, we will not let them onto the production cluster. It's just like a green lighting mechanism, and that's very effective for them.
Yeah.
So those are four examples of...
Yeah. Perfect. Yeah. So what's... you're sort of looking back through the kind of announcements and things, you sort of slowly over time adding more and more platform support, more and more features. But what's next? What's on the roadmap for next kind of major features?
Right. So you can imagine that we will continue helping developers. So you'll see more developer tools as well coming from us. But I think the most significant area that we're investing in right now is that part of our product is that we get information about all of our customers' clusters at every 5-second interval. So we see every task, every job, every user, every queue, which means we're collecting trillions of data points. So far we've collected probably on the order of 300 trillion data points on how the servers work. And sort of at a very fine-grained level, we are now applying some deep learning to exploit that and be able to make not only our tools better, but also to give much more insight and the ability to predict things for our customers.
Yeah, it's interesting. I've done some interviews with some companies that do. They're probably already at that stage, but in the more traditional application space,
right?
Especially JVM based, I think is traditionally fairly popular for a variety of reasons. In doing similar things, not just code analysis, but actual smart analysis of the code, and also the ability. It sort of applies more, of course, in application code to pinpoint problems in production as well, which is slightly
so you have to be careful here.
Yeah.
Right. So you have to be careful here, right? So no. I just want to point out an interesting nuance here. So deep learning has two components to it. Obviously, the learning component and building the right algorithms, but it also has the data component. The thing that I want to point out here is the data that we have is extremely large and proprietary. No one else has this type of data because no one else has been watching these servers. I would say with the exception of people like Google and Yahoo and the large providers, no one else has this type of data. Certainly, no one else has this type of data on production systems inside large enterprises. And it's the combination of proprietary data plus the algorithms that allow you to do things that are completely unique.
No, for sure. I just mean in terms of with similar ideas, but in a different space, I guess.
Yeah.
That's what I meant. Yeah.
Indeed.
Cool. Okay. And I guess actually one thing we haven't completely. I'm guessing people will probably guess from how I've described things, but it's basically some sort of web GUI, I guess, dashboards, etc. What's the level of finesse you can kind of direct people to in terms of pinpointing issues or potential issues?
So first of all, it is a web UI, right? And it's based on React, so it's fully configured appropriately on every device you can look at it. So it doesn't matter, right? So it's completely conforming to that. In terms of being able to pinpoint to types of issues, we can literally pinpoint a specific disk and tell you that is about to fail, right? We can tell you a specific network interface card that's giving you issues, right? We can point to a specific job and a specific task within a job that's causing the problem, right? And going to the Spark world, we can tell you specifically which executor for which stage was causing the issue. So very, very detailed understanding of what's going on.
And can you do this no matter what the infrastructure, whether it's on-premise, cloud, container-based, VM-based, you can do all levels?
Correct.
Okay.
Correct.
Okay. Yeah. Excellent. Okay.
And by the way, we have instances of customers
Yeah.
across everything that you just mentioned.
Okay. Okay.
So this is not theoretical; it's real.
Yeah, no, for sure. And I guess a question I like to ask, especially with companies that provide kind of infrastructure or infrastructure analysis for other companies, is does Pepperdata use Pepperdata?
Of course.
Good.
Look. One thing we learned a long time ago is dog fooding is probably the single most important thing you can do. So yes, we absolutely use it for ourselves. And the interesting thing is this: I'll make the following observation. People ask us, well, since you're getting so much data, you must be using up significant portions of the cluster. It turns out that if you want to see us on the cluster, you have to use us. We take less than 1% of the resources.
And actually, I mean, that's also a question. Does do any of the I'm not sure what to call them, modules, whatever sort of generic word we want to use, what's the kind of performance overhead on applications? Much at all? Or?
That's what I said. Less than 1%.
Yeah. Okay. Excellent.
Yeah, it's less than 1%. So as I said, if you want to actually, with most classic tools that are available, if you wanted to see whether we were actually on the cluster, you wouldn't be able to see us.
All right.
You'd have to use us to see it.
So I think that's a good advertising slogan in itself. So minimal, you have to use us to see us, or something like that. I'm not an advertising person, so it was this. And I've had my particular questions I've wanted to ask, but I guess is there anything that I haven't mentioned that you haven't had a chance to mention that you want to make sure people know?
No, I think this has been great.
Okay, cool. And just out of interest, I mean, I can see, especially from press releases, which isn't the source of truth for everything, but so the company's been around for just over 2 years. Is that about right?
No. We've been around for 5 years.
Okay. So press releases are not the source of all truth.
we were formed 5 years ago. The investors are very solid. So it's Wing, Maynard Webb and his investment firm. City Ventures is an investor. Jerry Yang is an investor. Marissa Mayer is an investor. We have quite a all-star cast of investors. And
what was the motivation for the founders? Similar to yours? They came from backgrounds of struggling to answer these questions in the past?
Well, so Chad and Sean, particularly Sean, was actually at Yahoo while MapReduce and Hadoop were being developed. He was the first large-scale production user of Hadoop. Then after they left Yahoo, went to Bing, and they were thinking about what to do because they were getting bored at Microsoft. They realized that all of the production issues they were having at Yahoo, customers were seeing them. So they said, wow, we know how to solve those. Let's go start a company around it.
It's actually, I must admit, I came across a couple of articles where you've been interviewed before. I did not realize, sadly, forgive me for my ignorance, that Hadoop came out of Yahoo. I did not actually realize that.
Yeah. So. It's actually, it's arguable. So
it's often, I've heard many.
It's arguable.
I've heard many stories.
You could say Google and Yahoo. I would say it's probably a good smattering of both.
I've heard many stories of this. Like, I think I heard one recently of the origin story of Jenkins coming from Sun and the controversy around whether it did or not. And of course, then they got taken over and et cetera, and then it all gets very messy.
Well, the old story about the victor gets to write history.
Yeah, well, of course, yeah. Well, and the victor is not always the one that makes the most money out of it. So.
Correct. That's exactly correct. That is exactly correct. By the way, the prototypical example of that is relational databases.
Yeah.
So relational databases were actually invented at IBM Research. Yeah. And the person who made the most money on it is Oracle.
Yeah, no, of course, and they didn't even really make it in inverted commas. So
correct.
Correct. That opens up a whole other can of worms. So we won't go down there.
Yes, indeed.
Indeed. Excellent, interesting stuff. And I guess anyone who is interested in seeing how Pepperdata can help them, I get the impression that you're very much a kind of enterprise level SaaS company, so it's very much schedule a demo. But
exactly.
If anyone is interested, then
So that's actually an interesting point to double click on. That's a very interesting point to double click on. As we're focusing more and more towards developers and providing tools for developers, you can imagine that in not too long a future, we might actually have things for a developer base that you could download.
This is actually an interesting point. So I've worked in big data companies myself, predominantly in like developer relations fields. So not actually development work, but explaining the product to people. And demoing big data stuff is really hard because you have to try and find examples that make sense to people. But then how much time do you dedicate to building an application that the team of developers could spend 6 months developing? So it's a very hard area to demonstrate, especially like demos and things, because you can't replicate a data center on a laptop anyway.
Well, that's why part of our process for buying our what I would call the ops side of the tool set is that we actually run on their production cluster. That's part of our sales process, right? Think about this. We are a tiny little startup that goes into a place like Comcast and demands that they put us on a production cluster. The interesting thing is, I would say we were getting resistance, but now with the set of clients that we have and the references that we have, we no longer get any resistance from Fortune 200.